Okay, so now we're going to talk about factoring sum and difference of cubes. So the way this is usually taught is that they tell you that you have this formula, a cubed plus b cubed. Whenever you have something in the situation of a cubed plus b cubed, it's going to equal to something. And that something that it's equal to is a plus b times a squared minus ab plus b squared. Okay? And then you're asked to memorize it. And so if I give you a situation like x cubed plus 125, you just substituted the formula. So x cubed is a cubed. So if these are equivalent, then if I have just a, then that just tells me take the cube root of x cubed, which is x. And apply the same thing with 125. So that is 125 is b cubed. So if you take the cube root of 125, you get 5. Let me make that look more like a 5. Okay. So again, if you need some visualization, I'm saying a cubed is equal to x cubed for the first part. And so if you take the cube root of both sides, you get a is x. And then I'm saying b cubed is equal to 125 for the second part. And if you take the cube root of that, you get b to be 5. So that's how I'm getting this x and this 5 here. Okay? Now, let me actually erase all of this. Give myself a little more space. Okay. All right, so with that being said, then we go through and we look at this, and then it says a squared. Well, we're saying a is x, so then when we square x, we get x squared. And then it's minus ab, which is if x is a and 5 is b, then you multiply them together and you get x times 5, or simply 5x. And to finish it off, you add the squaring of b. So if b is 5, it's 5 squared, which is 25. And there we have it. And there's your answer. So this is the traditional way of doing this. I actually don't like this too much because I think you're so stuck to the formula. So what I do, let's do an example. Let's say I give you x cubed plus 27. Okay. I think of it almost as a dance. So you take the cube root. I just memorize. You start off taking the cube root of x of the first one. So the cube root of x cubed is just x. You take the cube root of 27, which is 3. Okay. Then you simply square the first one, and then you square the last one. And when you do this, you put the last one in the back, and the middle is just the product. So x times 3 is 3x. Okay? And then with the signs, you go same, different, positive. So because it's positive, same is positive. This is originally positive, so this is positive. Different, so then it's negative. And the last one's going to be, the last one's always positive. Same, different, positive. San Diego Padres. Okay? Let's do another example real fast. Let's say I give you x cubed plus 8. Okay? So all I have to do is take the cube root of x cubed. That's x. Take the cube root of 8. That's 2. This is plus, so this is plus. I'm going to go down here and finish it off. And then what do we do in the second part? You just square this one. You just square this one. And then the middle is just the product of the two. Same, different, positive. And that's it. The cool thing too about this is we have just been doing the sum of cubes, but there's also a thing called the difference of cubes, and the only thing that happens is when it's negative, you just switch here. Note in the last part here, this is still positive. Okay, we're just switching the signs. So let's do an example real fast. Let's say I give you x cubed minus 125. You just tackle it the same way. So what do? I just go through and I say, okay, what's the cube root of x cubed? X. What's the cube root of 125? 5. Parentheses. You square x. square 5. In the middle is the product. Same. Sorry. So used to adding. Same. Now this is negative, so this is negative. Different. So positive. And the last one's going to always be positive. And there you have it. X minus 5 times x squared plus 5x plus 25. And that's your answer. So hopefully that makes sense. In the next couple videos, I'll be showing more advanced situations of this.